Now students, that we are aware of what are quadratic equations, let me take more examples to understand few topics in detail. The first example, 5x squared plus 2x plus 1 is equal to 0. The second one, y squared minus 2y is equal to 0. Let's take one more. R squared minus 7 is equal to 0. So what do you see in these three examples? All these examples are examples of quadratic equations. Now look at the terms, children. Look at the first one. All the three terms are arranged in the descending power of the variable. First term contains x raised to 2. The second term contains x raised to 1. And what about the third term? The third term contains x to the power of 0. As we have learnt in indices, anything raised to 0 is always equal to 1. So even though in the last term the variable x is missing, it is very much present with the power of 0, and that is equal to 1. So anything multiplied by 1 is the same number itself. So what did we see over here, children? We saw that all the terms are arranged in the descending power of the variable. Let's move on. See the second example. Y square minus 2y is equal to 0. In fact, this is also a quadratic equation. But you can see that the last term is missing. You have y raised to 2 as the first term, 2y as the second term. Over here, y is raised to 1. But what is missing? The third term is missing. Let's move on with the third example. Look at the third example, children. R squared minus 7 is equal to 0. Again over here the variable is r. It is raised to 2. So it's a quadratic equation, definitely. Over here what is missing? The term with the power of 1 to the variable is missing. That means the middle term r raised to 1 is missing. You have the last term over here as minus 7. Even though some terms are missing in few examples, all these examples are examples of quadratic equation. So let's form a generalization of what a quadratic equation can be written as. So the general form of a quadratic equation can be summarized and written as ax square plus bx plus c is equal to 0. Again look over here, children. The variable is x over here. The first term, it is raised to 2. The second term, x is raised to 1. In the third term, even though it is missing, it is very much present. It is c x raised to 0. So in the general form of a quadratic equation, you arrange the terms in the descending power of the variable. Now further on, children, what is a, b, c? Over here, a, b, c are all real numbers. Once again I repeat, a, b, c are real numbers, right? But what is the condition? The condition over here will be a should never be equal to 0. A should never be equal to 0. Now let's understand, children, why this condition is there that a should never be equal to 0. Let's think otherwise. If a is 0, then what happens, children? 0 into x squared is what? 0 into any term is always 0. So what happens to this term? If a is equal to 0, then a x square also becomes equal to 0. And if this term is 0, then what are you left with? You are left with only dx plus c is equal to 0. That means the power of the variable x becomes 1. So can you call it as a quadratic equation? Definitely not. You cannot call it as a quadratic equation. That's why this condition prevails, that if a, b, c are real numbers, a can never be equal to 0. Okay children? Now let's move on further children. You have understood what are quadratic equations. You have understood the general form of a quadratic equation. Now how do you arrange all the terms in a general form? Always in the descending power of the variable, whichever is present in that problem. Okay? Now let's understand roots. Roots of a quadratic equation. First, I'll write down what do you mean by roots of a quadratic equation. Now, you can say that values of the variable which satisfy the given quadratic equation are called roots of that quadratic equation. Once again I repeat children, what are roots of a quadratic equation? It means the values of the variable. The values of the variable in any quadratic equation which satisfy the given quadratic equation will be called as the roots of the given quadratic equation. Let's understand this more precisely by taking examples children. Let me take an example. First one, let me take an equation 5n square plus 4 is equal to 0, where the value of the variable m over here is equal to 1, or you can say is equal to 4. We have to determine if the value of m can be roots of the given equation. Once again I repeat, given quadratic equation is 5m square plus 4 is equal to 0. The values given for m, the variable present in the equation is 1 and 4. You have to determine if m equal to 1 or m equal to 4, or both of them can be called as roots of the given quadratic equation. Now children, you have already studied in case of polynomials how you determine the roots. Same procedure will be applied over here. So let's see how to solve. First, write down the equation. Five m square plus 4 is equal to 0. Let's take one value at a time. So first, let m is equal to 1. Now how do you determine if it's a root or not children? Let's recall back. We take the value substitute in the given equation to the left and to the right wherever the variable is present, and then solve your left hand side of the equation, solve your right hand side separately, and check if both the answers tally. That means if both the answers that you receive, that you get on your left hand side is equal to the right hand side. If both the answers are right, then the given value is the root of the given quadratic equation. So let's start, children. I'll divide the board. This is my left hand side of the quadratic equation. This I will term it as the right hand side. On the left hand side, what do I have? I have the expression 5n square plus 4. Let's solve it and get the answer. Over here, 5, when there is no operation, it is taken as multiplication. So 5 into, what is the value of m that we have taken first is 1. 1 raised to 2 plus 4. So over here, 1 square, children, is 1. 1 into 5 is 5 plus 4. So what is the answer? 5 plus 4 is 9. So your answer on the left hand side is 9. Now let's solve the right hand side of the given quadratic equation. Do you have any expressions over here? No, we do not have any expression. We have only the term 0. So there is no need to solve anything by substituting the value of m. The answer already on the right hand side is 0. So the answer on the left hand side is 9. The answer on the right hand side is 0. Is 9 equal to 0, children? Definitely not. So what do we write? Further, we write that as 9 is not equal to 0, therefore left hand side is not equal to your right hand side. So what do we conclude? We can conclude that m equal to 1 is not a root of which equation, children? 5n square plus 4 is equal to 0. 5n square plus 4 is equal to 0. So in case of the first value, we have got that it is not a root. Similarly, have we ended with this problem? No. We have one more value to find out. So again, let's repeat the same steps. But what is the difference? Here we will substitute the value of m as 4. So let's start, children. Again, I rewrite the equation. Now I will write let m is equal to 4. I divide my blackboard into 2. Left hand side, right hand side. So what is my left hand side of the given quadratic equation? I write it down. 5n square plus 4. Now let's substitute the value of m. 5 into, what is the value of m? 4. 4 square plus 4. So 5 into 4 4s are, children, 16 plus 4. If you had a minus sign, you would have put a minus sign. So please check the signs of the algebraic expressions. Is it clear, children? Now 16 into 5 or 5 into 16 is 80 plus 4. So the answer on the left hand side is 84. Now, children, to your right hand side. What is there on the right hand side? Only a numerical constant, that is 0. Now check your answers on both the sides. One is 84 on the left hand side. The other answer on the right hand side is 0. So are they equal? Are the answers on the left hand side and right hand side equal? Definitely not. So what will we write? 84 is not equal to 0. Therefore, left hand side answer is not equal to right hand side. So can you term m equal to 4 as the root of the quadratic equation? Definitely not. Therefore, m equal to 4 is not a root of the given equation. So children, what did we study over here? We studied the general form of a quadratic equation, which is ax square plus bx plus c is equal to 0, as well as we studied what can be termed as roots of a quadratic equation. Now children, for some activity time, let's see what's written on the board. One of the roots of the given quadratic equation 5n square plus 2n plus k is equal to 0 is minus 7 upon 5. We have to complete the following table to find the value of k. Now first let's understand the language of the problem, what is given and what you have to find out. Now once again let's repeat. They have given you a quadratic equation 5m square plus 2m plus k is equal to 0, where the value of m is given as minus 7 upon 5. So you have to find out by substituting the value of m as minus 7 upon 5 to find the value of k, which is also unknown over there in the given quadratic equation. Now let's see, how do we fill up the boxes? Over here children, dash is a root of the given quadratic equation of 5n square plus 2m plus k is equal to 0. So who is given as a root of the given quadratic equation? Minus 7 upon 5 is one of the roots which are given as the root of the given quadratic equation. By substituting minus 7 upon 5 in place of m in the given quadratic equation, we will try to find out the unknown value, that is value of k. So next sentence, put m equal to the given value. Let's substitute as minus 7 upon 5 in the given equation. So let's substitute children. 5 into m square. So the value of m given over here is minus 7 upon 5. Do not forget the sign before it. The whole square as it is, plus 2 into m. So plus 2 into m. Again the value of m is minus 7 upon 5 plus k is equal to 0. So what did we do in this second statement children? Wherever there is m, we have substituted the value of m, which is given as minus 7 upon 5. Let's continue to solve this and fill up the next boxes. Over here children, let's solve this in the rough work column so that we do not go wrong. 5 into, and write it down, 5 into minus 7 upon 5 the whole square plus 2 into minus 7 upon 5 plus k, which is equal to 0. I've just rewritten it in the rough work column so that we know what are the answers of these boxes, right? So now let's solve and see what do we get over here for the first box. Minus 7 upon 5 into minus 7 upon 5. So over here, minus 7 upon 5 as it is square. This is the first term. Plus into minus is minus. 2 sevens are 14 upon 5 plus k, which is equal to 0. Now, let's solve this children. Here we can reduce 5. 5 ones are 5, 5 ones are 5. Let's see what answer do we get. Minus into minus becomes plus. 7 into 7 is 49 upon 5 ones are 5 minus 14 upon 5 plus k, which is equal to 0. Now I am ready with the answers. What should be inserted in box 1? What should be inserted in box 2? Plus k, which is equal to 0. Let's write it down, children. So in the first box, when you solve this term, you get the answer 49 upon 5. Here they have given you a plus sign. So inside the term goes as it is with the negative sign. Plus k, which is equal to 0. Now children, let's look at the next box. You have only one box. Plus k, which is equal to 0. That means definitely we have to plug up the first and the second box, find out the answer and rewrite the answer in the first box, continued with plus k equal to 0. Again, let's do it in the rough work column. Let's write down 49 upon 5 plus into bracket minus 14 upon 5 plus k, which is equal to 0. Let's solve the first two and find out the answer. So 49 upon 5, bracket means which operation, children? It is multiplication. So plus into minus gives you minus 14 upon 5 plus k, which is equal to 0. Let's solve the first and the second term. Both are having the same denominator 5. So it goes under the same denominator 5. Numerators as it is, 49 minus 14. If you had a plus sign, you would have inserted a plus sign. But as you have a minus, write it with a minus. Plus k, which is equal to 0. Now children, look at the numerator. 49 minus 14. What are you left with? You are left with 35 upon 5 plus k, which is equal to 0. Can I write this as the answer? Let's check. 35 upon 5. You can still reduce it. How do you reduce it? 5 ones are 5 sevens are. So what are you left with, children? 7 upon 1 plus k is equal to 0, which goes as only 7 plus k is equal to 0. So I'll write the answer 7 plus k, which is equal to 0. Let's move on to solve the problem. Now, in the next and the last concluding step, you have only k, which is equal to an empty box. Now we know we have to find out only the value of the unknown variable, that is k. 7 has an addition sign. It is to your left hand side of your equation. When it is transferred to your right hand side, positive becomes negative. So plus 7 becomes minus 7. So ultimately you come with the answer for the unknown k, which stands as minus 7. Children, now let's proceed with few examples more. On the board you can see the question, determine whether the given examples are quadratic equations or not. The first one is a plus 1 upon a is equal to 2 and the second one is a square plus 1 upon a is equal to 2. Let's solve the first one and find out if it's a quadratic equation or not. Now pay attention, children. In this given example, you see a plus 1 upon a on the left hand side. So you have a denominator for the second term. So you know in this case we have to find out the LCM. When you have only a, what is the denominator for a? It is 1. So what do you do? In this case either you cross multiply and multiply the denominator. So what do you get? A into a is a square plus 1 into 1 is 1 upon the operation of multiplication for the two denominators gives you 1 into a is 1a, which can only be written as a, which is equal to 2. Now children, let's take a on the other side and decide. So a square plus 1. A is performing the operation of division on the left hand side. So when it is transferred on the right hand side, it operates as multiplication. So it becomes 2 into a. So finally you get a square plus 1, which is equal to 2a. Now looking at the answer that we get, the highest degree, the highest power of the variable a is 2. So the given equation is a quadratic equation. So yes, it is a quadratic equation. Let's see the second one. In the second one, we apply the same procedure for each and every step. So you have a square plus 1 upon a, which is equal to 2. Let's only concentrate on the left hand side first. You have a square, that means you have a square upon 1 as the denominator. Let's put it under a common denominator, that is your LCM method. So a square into a will give me a cubed plus 1 multiplied by 1 is 1 upon 1 into a again gives me a, which is equal to, on your right hand side, you're left with 2. Now children, a, which is in the denominator, performing the operation of division on the left hand side, should be transferred on your right hand side. So division becomes multiplication. So you have a cubed plus 1, which is equal to 2 into a. So a cubed plus 1, which is equal to 2a. Without solving further, here we see that the highest power, the degree of the variable a is 3. So can you call it as a quadratic equation? Definitely not, because the highest power of the variable in that given problem should be 2. So over here you have 3 as the highest power. So it is definitely not a quadratic equation. So no, it is not a quadratic equation. So children, what have we studied? Before finding and writing if it's a quadratic equation or not, solve it stepwise as per the requirement of the problem, and then decide if it's a quadratic equation or not.